Good afternoon, everyone. I am Rani, working as an assistant professor in the Department of CSC at Mlritm. Today's session we will discuss about network programming. Network programming are course outcomes. Understand basic of network programming and sockets. Write socket API based programs. Design and implement client server applications using TCP and UDP sockets. Analyze network programs, applying multicasting. Introduction to network programming and sockets. Network programming and sockets are nothing but network programming is the process of developing applications that communication over a network. It enables data exchange between devices using protocols like HTTP, FTP and TCP/IP. A socket is nothing but an endpoint communication identified by an IP address and port number. Sockets support client-server communication using TCP, reliable, or UDP, fast but unreliable. Next, what is network programming? Network programming is nothing but the development of software applications that communication and exchange data over computer networks such as LAN or the internet. It uses standard protocol like TCP/IP, HTTP and FTP to ensure reliable and structured communication between devices. In network programming, process typically follow a client-server architecture, while client requests services and server respond to those requests. It involves the use of sockets, which act as an endpoints identified by an IP addresses and port number, enabling efficient data transmission between systems. For example, this is the network and these are the users, client server. Use of network programming. It deals with sending and receiving data between systems through sockets. It involves client-server communication where one system client requests data and another server responds. Uses protocol like TCP/IP, Transmission Control Protocol, and Internet Protocol, and UDP, User Datagram Protocol, for reliable or fast data transfer. Makes it possible to connect device globally, forming the backbone of the internet and distributed system. Enables communication between computer over a network. Used in web applications, for example, browsing web services. Supports email systems for sending and receiving messages. Helps the file transfer. For examples, uploading and downloading files. Used in chat application and messaging systems. For example, internet, firewall, wireless router. Wireless routers are IP connections and printer, desktop, laptop. These are the architecture. For example, another resource sharing. Resource sharing means is internet to connectivity, router connectivity to switches connectivity to ring topologies, and switches connectivity to scanner or printer or desktops. These are the resource sharing. And web browsing, HTTP, accessing website using browsers, client server communication. These are the examples. Email system means SMTP, POP3, IMAP, sending and receiving emails over the network. File transfer FTP, uploading and downloading files between client and server. Chat applications, real-time messaging between users, for example, WhatsApp concept. Online gaming, multiplayer game communication, communicating over the internet. Video streaming, watching video and platform like YouTube. Remote login, SSH telnet, accessing and controlling a remote computer. Cloud services, storing and accessing data from cloud servers. DNS services, converting domain name into IP addresses. IoT applications, communication between smart devices, for example, sensor and smartphones. Next, OSI models. OSI models are 7 layers. These are the 7 layers are OSI models. OSI model is conceptual framework used to understand how data transmitted over a network. It divides the communication process into 7 layers. First one, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. And these are the 7 layers. Each layer has a specific function such as data transmission, error and detection, routing and data formatting. The OSI model helps in standardizing network communication, making it easier for different systems and technologies to interact with each other. It also simplifies troubleshooting, allowing network issues to be identified within specific layers, thereby improving network design and management. This is the flowchart of the OSI model. First one, application layer is used for user interfaces. Next, presentation layer used for data transactions. Session layer is used managing connections. Transport layer, this is the used for reliable data transfer. Next, network layer. Network layer is path determination. Data link layer. Data link layer is physical addressing. Last one, physical layer. Physical layer is bits in byte. First one, physical layer is nothing but transmit the raw bits over a physical medium. For example, includes cable, signals, hardware, hubs, repeaters, byte and radio signals. The physical layer is the first and lowest layer, the OSI model, responsible for transmitting raw data bits, zeros and ones over a communication. It deals with the physical connection between device, includes cables, connectors and transmission media. This layer defines electrical and mechanical and signal specifications such as voltage levels, data rates and transmission modes. It ensures the data transmitted in the form of signals. For example, electrical, optical or radio from one device to another device. Second one, data link layer. Data link layer is ensure error-free transfer between two devices on the same network. For example, uses MAC. MAC means Media Access Control Addresses. Examples, Ethernet, switches, PPP, point-to-point protocol. The data link layer is second layer of the OSI model and is responsible for reliable data transfer between two directly connected devices. It receives raw bits from the physical layer and organization them into frames. This layer performs error detection and correction, flow control, and ensure proper data delivery. It also uses MAC, media access control addresses, to identify devices within the same network. Next, third one, network layer. Network layer handles logical addressing and routing. Find the best path for data. Protocols: IP, ICMP, OSPF, RIP. ICMP, Internet Control Message Protocol. OSPF, Open Shortest Path First. RIP, Routing Information Protocol. The network layer is the third layer of the OSI model and responsible for routing and forwarding data from one source to destination across multiple networks. It converts data into packets and determines the best path to data transmission using logical addressing such as IP addresses. This layer handles tasks like routing, path selection, and congestion control, ensuring that data reaches the correct destination efficiently. Fourth one, transport layer. Transport layer ensures reliable or unreliable delivery. Provides segmentation, flow control, error control. For examples, TCP and UDP. The transport layer is the fourth layer of OSI model and it is responsible for end-to-end communication between devices. It ensures reliable data transfer through error detection and correction and flow control. This layer segmentation into smaller units and reassemble them at the destination. It uses protocols like TCP reliable and UDP fast but unreliable to manage data transmission. Fifth one, session layer. Session layer is manages session between devices, handles opening, closing, and maintaining sessions. For examples, remote procedure call, network bias input-output systems. The session layer is the fifth layer of the OSI model and it is responsible for establishing, managing, and terminating communication session between devices. It controls the dialogue between application, ensures proper synchronization and coordination during the data exchanging. This layer also provides session checkpoints and recovery mechanism to resume communication case of interruption. Sixth one, presentation layer. Translates the data between application and network. Handles encryption, compression, encoding. For example, secure socket layer and transport layer security, joint photography, expert group, and MP3. The presentation layer is the sixth layer of the OSI model and is responsible for data presentation and formatting. It translates the data between the application layer and network format, ensuring compatibility between different systems. It translates data between the application layer and network format, ensuring compatibility between different systems. This layer handles functions such as data encryption, decryption, compression, and conversions. For example, text and images. It ensures that data is presented in a reliable format for the application layer. Last one, application layer. It is closest to the users, provides network services to applications. For examples, hypertext transfer protocol, file transfer protocol, simple mail transfer protocol, domain name systems. The application layer is the seventh one and topmost layer of the OSI model. The application layer is the seventh and topmost layer of the OSI model, responsible for providing network services directly to end users and applications. It enables user interaction within the network through services like web browsing, email, file transfer, and remote access. This layer uses protocols such as HTTP, FTP, SMTP, and DNS to facilitate communication between software application and the network. For examples, imagine you are sending WhatsApp messages to your friend. First one, application layer is you type the message in WhatsApp. Next, presentation layer, the message is converted into suitable format. Session layer, a session layer is created between your phone and your friend phones. Transport layer, message is divided into smaller packets, TCP and UDP. Network layer, each packet is given IP address to find the destination. Data link layer, packets are formed and sent through the network card. Physical layer, bits, zeros and ones travel through Wi-Fi or cable. This is the example for OSI model. Application, presentation layer, session layer. This is the sender. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. This is the receiver. These are the references, textbooks and references. Thank you, sir.